Welcome to The Confidence Interval, a brand new podcast from the MRC Epidemiology Unit at the University of Cambridge, talking science, people and public health. We'll be using this podcast to explore the research happening at the MRC Epidemiology Unit, meet some of our researchers and find out what makes them tick. I'm Oliver Francis, Head of Communications for the unit, and with me, the first victim for the hot chair is Dr. Felix Day. Welcome, Felix.
Hi.
Felix is a Career Development Fellow in the Growth and Development Programme here. The programme is researching the mechanisms that link growth and development to risks for obesity and type 2 diabetes, and they're using this to inform early life interventions to prevent these and other metabolic diseases. Felix's own research is centred on understanding the genetics of puberty and reproductive ageing, as well as investigating how these relate to later life outcomes. So Felix, people tend to think of puberty as something that happens, and then we never have to think about it again, thank God. But it's not as straightforward as that, is it? How and when it happens can affect the rest of our lives and be affected by all sorts of genetic and environmental factors. For example, you were involved in a study that found that the timing of puberty has wide-ranging impacts on health in later life. Tell me a bit about that research.
Well, yeah, puberty is a very important time in human development. It's this time when we stop being a child, effectively, and turn into an adult, and there's a whole range of changes that happen at that point. And these often have long-lasting consequences in terms of downstream diseases. So broadly, the three elements that we found as part of that research was that there were a set of reproductive cancers, where the risk was increased if you had earlier puberty, and this is the case for both men and women. And we kind of understand that because we understand that that's about the hormones circulating around your body. You would have more exposure to your sort of reproductive hormones if you have earlier puberty, and that's what probably causes the cancer. The other side of it is that we've known for a long time that there's a link between how your body senses the amount of energy it has, either in itself or in the environment, and whether it feels prepared to, and this is particularly the case in women, to make another human being. So there's a clear links between metabolic disease and puberty. People who go through puberty earlier tend to have higher BMI, both in childhood, before puberty, and afterwards, and the range of conditions associated with higher BMI. But then at the same time, we also found that there's a range of what we thought of as more psychosocial conditions, the classic one being depression. And actually, when we looked at the data, we found that people who either go through puberty much later or much earlier than their cohort tend to have increased risk of depression and depression-like symptoms in later life.
Why do you think that is? What do you think is going on there?
Well, I think it's partly because puberty is not just a biological change, but it's a major social change. And that and we have no data to support any of the points on this particular pathway that I'm talking about, but if you go through a period of what is very drastic change at a time when you are very different to your friends who are going through that a different way, that could be something that might have sort of major psychological effects on you.
So it's that the change is perhaps causative of something else, rather than the change is an indicator of other factors that might lead to these final outcomes. Is that what you're saying?
Yes, I think this is often something that we find in quite a lot of epidemiology, is that what we're looking at is a pathway. It's not just a sort of a simple relationship between one thing and another thing. The social construct of puberty is probably equally as important as the sort of the hormonal changes in terms of some of the later life conditions. But we also see it in terms of, say, not just how you might conceivably engage with your friends, but how you might engage with school. If suddenly you've got people who've gone through puberty a lot earlier, they might suddenly be better at sports or something. Then they might have developed more muscle mass. There's a whole range of changes that are happening at this particular time point.
Because correct me if I'm wrong, but I think some of the received wisdom was, for example, that if you were overweight, you were more likely to have early puberty, and that overweight was then associated with diseases later in life. And you're saying that it's not just that; there are other factors involved in.
So using various statistical methods, even when we take into account a childhood propensity for higher BMI, puberty appears to have a particular effect, particularly on early puberty on type 2 diabetes, for example. There seems to be an effect of increased BMI for younger ages, an effect of that increased BMI on puberty, and an effect of puberty itself. So in people who have higher BMI at early ages, you almost get this sort of like triple whammy of effects. And of course, teasing these out is often quite complicated, the data. We don't necessarily have all the data we'd like, but certainly our best understanding of it is that there is a particular importance to puberty timing.
And one of the data issues you have is that you're looking at people who are older, and you have to find out retrospectively when they went through puberty.
Yes.
And that has to be through what? Through self-report?
Well, so in a small number of cases we are very lucky in that there are, certainly in the UK has pioneered this, a number of sort of birth cohorts. There's one set up as part of the sort of general foundation of the NHS. So this actually has sort of regular measurements of people, some of whom have now, are very advanced in old age and some of whom have died. And in those sorts of studies, we actually have a clinician verified timing of at least, within a year window of where we're going. But most of the time, we're having to ask people who are old enough to have got the sorts of diseases we're interested in about when it was they had puberty. And there's a definite gender split in this. Women, in most cases, have a much more specific, memorable point. It's the time when their periods start. When we want to do this sort of research and looking at puberty in boys, it's much more difficult. People don't really remember. There's no one defining moment. We ask questions like, when did your voice break? When did you start shaving? But, we generally find that unless you were singing at the time, you can't actually remember some of these sorts of things.
Yeah, I think it would be quite hard to put a precise date on that. Can you ask people if they felt that their voice broke, for example, late in relation to their peers? Because that's something that, probably because you're bullied at school, if your voice breaks late, you remember.
it's a psychological time at this point. And yes, the other thing that often happens is that sometimes we don't just ask people in a room with a questionnaire sheet, that we give them a sheet that they can fill out in their own time. And, speaking from personal experience, I can't remember when my voice broke. But when I was talking about this to my parents, they could remember, because they could remember a particularly embarrassing school carol concert in which I was noticeably audible as I varied wildly in the notes I was singing.
Just to come in, you want your parents to remind you of, isn't it?
Totally.
So, and given that there are strong genetic components in this, and it's not just about overweight and obesity, which is something you think you could try and intervene on, I guess, how should we worry? Should people worry about how their puberty ages are going to affect their later life? And actually, can we do anything about it?
So the second one is an interesting question. It's one we sort of occasionally grapple with. I think we're nowhere near a stage where we have, other than trying to reduce obesity in early childhood, we're nowhere near something where we have a direct intervention that responds to puberty specifically. We have a number of lines of evidence that point to maybe possibly something going on with vitamin A, but it's quite shaky at the moment, and a lot more work would need to go into that. I think the aim is probably not to have a sort of a population level intervention on puberty, other than the sorts of things that you would do in terms of diet and nutrition, and physical activity in children, but more that there are certainly groups of people who have very, very early puberty or very, very late puberty, and that there may be some sorts of interventions, some of which already exist for some particular causes of those, that might change them. Because if you think that being bullied because your voice was breaking sort of, a year later than all of your friends, if you're someone who's going through puberty aged 7 and you're a girl and you're in a primary school and they don't have facility to dispose of, sanitary towels or tampons or whatever it is you're using, that in itself is going to be quite problematic. So there are certainly situations in which, looking at the sort of the real extremes of the data, there may be some sort of intervention that's appropriate for those people. And
it's not just in early life these phenomena are important, but the things you've talked about in terms of puberty can affect menopause as well, can't they? Yeah, so these similar to depression, there looks like there's a U-shaped distribution with menopause, and that people who go through puberty much earlier and much later compared to their peers tend to have earlier menopause. And menopause also links into the reproductive cancer things, because again, that's the end of when you are exposed to your reproductive hormones. So if you think about
puberty being the start and menopause being the end, the totality of your exposure in those is probably one of the keys to the risk of breast cancer, prostate cancer, ovarian cancer, those sorts of cancers of reproductive tissues. And menopause is something that we've looked quite a lot at, trying to understand the genetics there. When it comes to menopause, it's less probably about cure. It's more about whether we're able to predict these sorts of things.
Because some, as I understand it, there's some that may be genetic that you're born with in terms of might detect your menopause, but also there's the thing that if you damage your DNA over life, that can bring on early menopause. Is that right?
Absolutely. So the single biggest factor, and this is pretty common to quite a lot of public health, is smoking. If you smoke, you will have menopause earlier in general. And the genetics is something that's actually quite interesting in terms of the biology. Quite often we think about genetics in terms of either a specific target for drug development or something related to risk prediction. And the hope was always that it might tell us something about sort of biology in general. But often we find we just don't know enough about the genome yet to really be able to piece together the whole big jigsaw puzzle of biology. But for the menopause, because DNA damage is something where there's a considerable amount of research by biochemists, by cellular biologists, we were able to look at what we were finding with the menopause and overlay it with that existing knowledge. And the vast majority of cases, it's about how your body preserves DNA. And if you think about oocyte biology, that makes quite a lot of sense. You're born with the total number of eggs you will ever have in your lifetime, and an important part of maintaining your reproductive capacity is how well you preserve those oocytes in a form that they are potentially able to go on to form children. And a major element of that is how well you can repair and detect DNA damage.
Felix, you talked about prediction of menopause. Why might that be important?
Well, the way we look at it is that the time of menopause is probably a reasonably important factor in terms of defining your fertility capacity. And there's a move in general in society, certainly in the UK and in Europe, to have children later and later in life. And there's quite a lot of research being done recently which shows that in terms of like idealised family size and realised family size, there's a bit of a disparity.
So when you say idealised, what do you mean by that?
Well, if you ask people how many children they would like, and then you ask people how many children they have, they're often about a child more than...
So they have more children than they wanted? Or
No, they want more children than they have.
And what do people say? Do they say 2?
I think they say on average about 1.8, and they would like about 2. Sorry, the other way around. So they would like about 2.8, and currently they're probably having about 1.8. Okay. And there are a bunch of reasons in which why that's the case, but
you probably explain that that's lots of people saying they want 3, some saying they want 2, rather than people saying they want 2.8 children.
A lot of this comes in rounding. Once you start doing averages and that sort of thing, this becomes sort of difficult. But some of it might be that their menopause time end of fertility for them, but also it drops off before that. And currently, the only way we can really give any information about the fertility levels and drop-off is a hormone called AMH. But it's only really informative in the last 5 years of fertility. But if we were able to use the genetics in order to identify either something that relates to the genetics themselves or to point to biology that we could then measure in a more informative way, this might mean that you could tell someone much earlier on in life that this was their sort of predicted fertility window. And quite a lot of the interventions we talk about when we're talking about public health are sort of motivational activity or sort of drugs. But providing people with information is quite cheap, is quite easy, and hopefully the bad side effects of some of the things that we provide in public health are minimised by that because it's a very low impact piece of information, but might potentially have a very important changes in people making their lives closer to how they would like to live them.
So, I mean, you've had perhaps an unconventional route to your current role. You could have been a historian.
Yeah, well, I had a application to university all written out with that in mind, and then to a certain extent I was walking down the corridor and my biology teacher went, hang on a second, Felix, I've just been reading something that might interest you, and went back and rewrote it and ended up applying for a course called Human Sciences, which I understand you were also...
Yeah, we have that in common, and it's funny because actually history was my other big thing at school, and I think that I probably learned as much, if not more, about how to be a good scientist from my history lessons at A-level than I did from my science lessons, because science, and it's probably better now, but it felt, back then, it was learning a list of facts. You didn't get much time to kind of learn to think around a problem scientifically. And in history, you had to, critical reading of sources, be aware of biases, kind of weighing up the relative strength of different, bits of information. And I loved it for that reason. And then, when I went on like you to do human sciences, it was fantastic because suddenly you were asked to think about these things. So it actually felt like a natural progression. And it was a really good first degree for a kind of general interested scientist because you would do genetics in the morning and sociology in the afternoon.
I think the thing that I really took away from it, apart from sort of like some specific subject knowledge, was the idea of there being different ways to think about things. And I think that's something that's really key in epidemiology.
And they're not in adversity to each other, they're complementary. Although it was interesting, whenever I took the stuff from sociology and anthropology to my biology lecturers or tutors, they were always really interested in it. If you took biology to the sociology tutorial, not so much, which was interesting. There's much greater resistance to consider biological aspects in social outcomes. And I can see, you go off on a great big tangent here, I can see why that is. But it was really gratifying when you would bring a bit of anthropology to an animal behaviour tutorial and they were really into it. So after human sciences, what comes next for you then?
So as I was coming to the end of my time in human sciences, I developed quite a serious illness. Slight epidemiological tangent. When we talk about identifying conditions in people, it turns out if you have severe abdominal pains and constantly throwing up, that's a symptom of a whole range of things, and getting an accurate diagnosis tends to be quite difficult. So questionnaire data needs to be good at specifying exactly the information you have out of some of your patients and individuals in your studies. But as having to take a year out, I also ended up quite fortuitously working in the malaria lab for about 3 months, doing a lot of stuff looking at microscopy on malarial parasites. And I think that sort of awoke in me a certain sort of interest in particularly applying some of the ways in which I kind of thinking to medical problems. And I think the link between human sciences and sort of some of the slightly more definitely epidemiology things that I think is really nice is that when I look around the unit now, there are anthropologists, there are sociologists, there are economics people, there are doctors, and it's, in a way, when you were talking about sort of history before, history has always seemed to me as a discipline defined by its methods, whereas epidemiology has always been a discipline defined by its problems. And to a certain extent, we don't really care how you've got to a solution to a problem if your solution works and is efficacious and effective.
And is methodologically sound.
And is methodologically sound, sure, yeah, absolutely.
And of course, there's still, despite being very interdisciplinary in the broader scientific community, there is still a slight sense of hierarchy of methods. The randomised controlled trial as the gold standard, and actually, often in epidemiology, you can't do that for various ethical and practical reasons. But in genetics, you can do something called Mendelian randomisation. How does that work?
Well, yes. I mean, I think partly it's something that grew out of the fact that we really can't do randomised controlled trials of genetics. There's no way we can currently, well, we might possibly in the near future with CRISPR be able to reliably change someone's genotype.
So what's CRISPR?
CRISPR is a technical term for a specific type of biochemistry editing where you can edit a specific site in the genome. Very exciting. I don't understand any of the biochemistry of how it works. But we can't currently change people's genome at random, as they do in a randomized controlled trial with an intervention at random. But there's this idea in genetics that while you inherit 50% of your genome from your mother and 50% from your father, the 50% that you get from your mother or your father is randomized. So there's this element of randomization in inheritance. And that we know that there are particular variants in the genome that affect a particular phenotype. I mean, this is why we do genetic epidemiology. We're trying to find those particular regions that have effect. Once we've found those, we can then see if there are other things that we think might be downstream of in the causal pathway and see what they affect. So going back to the example of puberty and cancer, one of the reasons we were able to really unambiguously link puberty timing to cancer is that when we look at variants that we have shown to associate with puberty, and we take those all together and give you a sort of a genetic propensity to early or late puberty, that genetic propensity statistically associates with cancer risk in later life. And in puberty we're quite lucky because we think the timing of these things works out. You know, you have puberty first, you get cancer in later life. So that's a clear relationship. But it's the basic idea of Mendelian randomization is it's taking variants that you know to be associated with something else and to see whether those are also associated with any of the downstream consequences. Something similar to with obesity and type 2 diabetes, with certain measures of insulin biology and polycystic ovary syndrome. All of these are about taking this combination of a clear genetic effect and the randomness that you get from the fact that you inherit some but not all of your genome from your parents.
There's a great Peter Medawar quote that he says, "There's no such thing as a scientific mind. Scientists are people of very dissimilar temperaments, doing different things in very different ways. Among scientists are collectors, classifiers, and compulsive tidy-uppers. Many are detectives by temperament, and many are explorers. Some are artists, and others artisans. There are poet scientists and philosopher scientists, and even a few mystics."
I would absolutely agree with that.
And you were talking about you were in a malaria lab, which feels a long way from studying genetics and puberty. And was it that you found that you were a kind of scientist who wanted to do a kind of thing, rather than a scientist who was interested in a particular problem? Did you want to think in a certain way?
So I like problem solving. I think in that quote I'm probably closest to the sort of like the detective type thing. I often am more interested in the process of solving the problem than the problem itself. I mean, I think if you were to sit me down and ask me at almost any point in my life whether I was going to specialise in reproductive biology, this would have been an unlikely answer. But there are some particular problems in that I particularly enjoy, and the way in which the team I'm in works on those problems I like a lot, and that's, I think, what keeps me focused on these particular problems. But I think also I'm always impressed in other people in science who do one of those other bits really, really well. There's a guy in the US called Dan MacArthur, who I think is probably and this is going to slightly sound like I'm doing him down, but he is absolutely the sort of stamp collector model of a scientist. He runs a thing called EXAC, which is trying to survey all of the rare pathological variants that exist globally. So these are things where just having this one change has a major effect on your health. And the resource that he has managed to craft out of that is amazing. And there are a number of examples of cases where the work that I do could not be done without the availability of huge data sets that other people have painstakingly provided. And then the other thing is you occasionally get those moments where you look at what someone else is doing and you go, that is a really, really neat idea. You know, that sort of moment of you go, the one I often come back to is Mary Lyons, who's the woman who did X chromosome inactivation. It was just this thought that, women have 2 copies of a chromosome that men only have 1 of, and maybe having 2 copies of an entire chromosome might cause a problem, so maybe one of them just doesn't do anything. And that, just as a really clear crystallizing idea, that's really neat. And I certainly don't think that my approach to things is either that absolute cataloguing of information, and despite my best efforts, is very rarely that sort of sudden spark of inspiration. But I think the things that I find I am good at is having a particular question and tenaciously searching down the answer. But that only works in a scenario where there are other people providing me with data that I can use, or having ideas that provoke questions that can be answered. And I think, again, talking about sort of the team I work in, I think the one thing that I've often been really inspired by, both sort of locally and public health in general, is how much of it is teamwork. That you have people who have strengths and weaknesses, but because you're working in general towards an aim, and some of these people I have never spoken to in my life. Some of these people just produce data or algorithms or code that mean that I can do what I do.
I presume you're talking about the wider scientific team, not colleagues in the unit.
I talked to most of those. But there's this sort of like general movement towards trying to get the best possible answers. And sure, there's a certain amount of competition, and there are people doing similar things than us, and occasionally they write a paper and we sit there and go, we wish we'd written that one. But there's a general movement towards everyone trying to chip in on the things they do best.
So you didn't solve the problem of malaria.
No, I did not. People still have malaria.
So how did you get from malaria to the unit?
Well, I don't know whether this is something you ever experienced, but I remember going around career days and talking to people, and they'd say, what course do you do? And one of my friends at that time was a mathematician, and he and I used to go to career days together, and I'd say I'm a human scientist, and he'd go, I'm a mathematician, and then spend the entire time talking to him because they knew what he did. And within the sort of the courses in human sciences, the 2 things that I was, I guess, best at were the statistics element and the genetics element. I mean, I really enjoyed all the other bits of the course, but those are the 2 things I thought I was best at.
It was known in my time as the pub quiz subject.
Yes, yeah, that.
Because you didn't specialise in anything, but you were really useful on a pub quiz team because you knew answers to the most obscure stuff.
And there was a not entirely unworn track that went from human sciences to the London School of Hygiene and Tropical Medicine in some format, and I applied to do a course there on epidemiology. Actually, speaking of malaria, that's probably what most of my personal statement was about, was, because that's what at that time I had the most experience of. So there was a certain, at that time, move towards infectious diseases sort of in my own head. While I was there, I think when you were talking about ways of working, that's when that really came out. Because broad as human sciences is, and it gives you a lot of bits to think about, I don't think the one thing it necessarily does is give you enough of a specialisation in any given area to know how you work best. It
doesn't qualify you for anything, but It doesn't disqualify you from anything either.
Absolutely. And the master's course, I think, did that for me. But what I really like is data. I mean, and this is the idea that I have, that it's a certain amount of detective work.
Goes back to Sherlock Holmes. Data, I need more data.
Yeah.
I cannot build a house without bricks.
I mean, often I sit at my desk wearing my deer stalk, trying things like that too. And when I was looking around for PhDs, the MSc Epidemiology had really good data. Certainly at the time, in terms of their access to large-scale population studies, which were well characterised and had good phenotype and long-standing records, they were probably the best place in the country. And they weren't particularly doing infectious diseases, but at that point I wasn't that fussed, because there was, what my interest was much more about having tools to answer questions. And I ended up doing a PhD which was predominantly focused on the genetics of BMI. And having finished that, there were sort of clear links between some of the stuff that I was doing in terms of the BMI and puberty, and I was already familiar with a lot of the genetic methods, and so the move from focusing on more anthropometric adiposity type phenotypes to something that was more reproductive was actually quite a smooth move.
So you've talked a bit about the research you've done so far. I sort of want to ask about what's next, but rather than just saying, what are you doing specifically, scientists are often asked what the big unanswered questions in their field, and I'm not sure that's very helpful anymore because grand unifying theories in biology are a bit few and far between these days. So is there a kind of a small, very specific question that you think is really important to be able to unpick?
So this may reflect my interest in answering questions rather than posing questions, but I actually think the thing I think is overlooked is a lot of the associations that we see in epidemiology are assumed to be linear, and there are mathematical reasons for making that assumption because it makes it easier to identify.
So when you say linear, you mean?
I mean, X increases, Y increases, and they increase at the same rate across all values of X.
So, for example, obesity goes up, cancer incidence goes up. That would be a
linear relationship. But one of the things we've seen, especially with doing the puberty sort of and later life diseases work, is that many of these associations aren't linear. That you actually have people who are at the extremes of the distribution are at increased risk, or that there's a tipping point and people start becoming at risk at a point, and actually up to that point there's not that much risk. And I think in my head, from a sort of philosophical point of view, it seems quite unlikely that a lot of biology is linear. I mean, there may well be a lot of biology that is linear, but that seems an assumption that I think is probably widely applied. So I think rather than saying what question do I think needs answering, I think it's more that there are questions out there to which there are existing answers, but that people could improve on knowing these sorts of things. And it comes in, this is not my area, but there's the public health statements of, say, the amount of fruit and veg a day. I mean, often these are based on linear models, and the considerations of where some tipping points might be might actually enable us to have a more accurate view of the sort of interventions that work in public health.
I think I find physical activity another good one in that the response at which the rate at which doing a little bit more has a very fast benefit means that actually if you can't do 30 minutes a day, which is a recommendation, it doesn't mean don't do any.
Yeah.
Because actually every minute you do pretty much up into that 30 minutes is probably having an increase.
Yeah.
And at 3 or 4 hours, it's probably not having as much of an impact. So you've done a fair amount of public engagement with the unit, and maybe you've touched on some of these already in this idea of linearity, maybe one of them. Do you come across a lot of sort of repeated misunderstandings of your field? Do people get the same thing, understand it wrongly again and again, or is it all sorts of different?
So the big one, and I think if you were to ask anyone working in genetics, they would probably say this one, is the nature-nurture debate, which everyone working in genetics, I think, is probably slightly frustrated that that's quite as nice an alliteration as it is, because I think that's its major selling point. It has two huge sort of monolithical issues with it, and the first is that it's never, and I can't think of any examples at all, one or the other. It is almost always both. And then the next problem with it is that many of the things that people think of as either nature or as nurture are a little bit both nature and nurture themselves. So, as an example of this, we've done some work with birth weight, and one of the things that influences how birth weight and this idea that the lower birth weight gives rise to a number of later life diseases, one of which is hypertension. But there's probably a pretty good argument that if your mother has high blood pressure, that affects her ability to provide you with an environment in the womb which makes you a bit smaller at birth, but also you inherit those genes. And there's certainly... And so my, again, philosophical approach on this is that there is probably nothing in humans that is measurable that doesn't have some genetic impact on the variability in humans. It might be tiny, and it might well be that is, again, acting through pathways that are modifiable environmentally or dependent on the environment to work, but that you could siphon off an area of human exposure and call this is nurture, this is nature, is, I think, a simplification. And sometimes simplification is very useful, but that is a simplification which is not useful at all.
And that's your program is trying to unify these different aspects, because you look at genetics, you look at growth and development, and you look at later out life outcomes. Yeah. So you're trying to say there aren't these kind of discrete points that before birth equals nature, after birth, or even during pregnancy equals nurture, or so on and so forth.
And to come back to sort of when you're talking about sort of the media, one of the things I found quite interesting was, having done bits and pieces linking genetics to BMI, there's certainly, when you're talking to reporters, an idea that this is kind of known, that all you're doing is just reinforcing this idea that yes, some element of obesity is probably genetic, but that sort of then sort of like shuts down the conversation, because of course it is. That's the nature part of the nature-nurture divide. But there was a paper we did a few years ago, which was looking on a slightly more controversial topic, which was the age at which people start having sex, which is an important point for reproductive and developmental processes. And this is also something that people don't intrinsically think of as having a genetic component. So there's almost like a pushback when you're talking to reporters of, how is the age at which you lost your virginity influenced by genetics at all? But that pushback slightly gives you a space to then start talking through this. And one of the things we were able to say was, well, puberty is genetic. Mm-hmm. And this is people who are developing some sexual characteristics, who have got reproductive hormones going through their body at earlier ages. Those people start having sex earlier. Yeah. There's a link between something that's genetic to something that people perceive as being biological to something that people perceive as being social. And once you can talk through that pathway, people start to sort of see your point of view. But if you're immediately put into that nature-nurture box, it's actually quite difficult to get out of it.
And presumably there are other psychosocial factors that could also influence this, that may be both nature and nurture in terms of risk-taking, for example.
Risk-taking is exactly an example that we found, that there's a variant called CADM2, gene called. The variant is in a gene called CADM2, I need to be precise about that. And people who have the particular variant that mean that you are likely to start having sex earlier also are more likely to speed on the motorway. I mean, it's a very broad risk-taking type. And I'm sure if we had data on people who do extreme sports, it would probably come up for those as well. But we don't happen to have that question asked.
So scientists need to read a lot for work. Do you find that you have any time or energy left for reading for pleasure? And if so, what?
I used to read a lot of non-fiction, and now I don't anymore. I think that's the one thing that's changed in my job.
Are there any kind of popular science books that really inspired you or changed your outlook? Because I remember reading a lot of books around the time I was applying for university, a lot of non-fiction biology, and I realise now that a lot of what I think about stuff has been informed by 20-year-old books, because I haven't reread them or reread the most recent ones, so I'm probably incorrect.
I think the two books I think that probably had sort of some sort of level of impact on me was when I was much younger. My aunt bought me a copy of a book called My Friend Mr. Leakey, which is not a particularly well-known book, but it was written by a guy called Haldane. And Haldane is one of the absolute founding fathers of population genetics, and there was a lot in sort of the Mr. Leakey books about sort of changing your perception on how you think about things. There's a reasonably well-known passage, if any passage out of this book is well-known, about the best place to eat mangoes is in the bath, because that means the juice, the fact that the juice goes everywhere makes no difference whatsoever. And that's just sort of taking slightly different approaches. And I think one of the things that I've always thought about the way in which Haldane thought, that he was certainly at odds with a lot of the people around him, and out of that being at odds with things came a lot of very, very interesting ideas, again, a lot of which we wouldn't be able to...
My favourite Haldane story, which is probably apocryphal, is that Popper said that the theory of evolution wasn't a proper scientific theory because it wasn't falsifiable. There wasn't an experimental finding that could refute it. To which Haldane replied, "Fossil rabbits in the Precambrian." Essentially, if you found a rabbit skeleton in a strata that was 500 million years old, you knew instantly that evolution had to be completely rewritten. And nothing else.
It was clearly very, very bright, but and he had a lot of very important ideas that influenced sort of the development of the field, but in slightly the same way as Ronald Fisher. I think there were certain moments where going off on a tangent kind of hampered some of his thinking. But in terms of sort of like a slightly more sort of scientific book, I think the book that really captured my imagination when I was growing up was Guns, Germs and Steel by Jared Diamond.
No, The Rise and Fall of the Third Chimpanzee was one for me.
Okay.
That was, I think, one of those books I was reading around the time I started going to university, and that was really kind of...
And I've reread it. And
very human sciencey book, isn't it?
Hugely human science, yeah. But I've reread it, and it's odd because there are certain specific elements in the book that now I know a little bit more about some of the subjects that I don't agree with him on. But the overarching big picture and being able to draw on various different sources of evidence to construct this hypothesis is sort of a really interesting read in terms of looking at ways to approach a problem. Yeah, and I think that, even though now there are certain bits where I go, that's not right, it's that big picture, broad brushstrokes is still very impressive to read.
Dr. Felix Day, thank you very much.
Thank you.